Good morning. It's good to be back. I apologize for being away as long as I have, but unfortunately I have to work for a living and have been putting in some long hours lately, so it's kind of cut into my free time. But with this 3-day weekend upon us, I managed to squeeze in enough time to crank out another video here. Hopefully we can finish this project up. I have what's left to do. We have the mounting bracket and that little backing plate, both steel parts. Should be able to crank those out in this video. I have received a lot of emails from people who have forged ahead and finished the project up without me. Surprise, surprise. But it's a good thing. Most of the comments I've received and most of the feedback has been positive. Looks like it's a good project and something you'll be able to use a lot when it's finished. So with that said, let's get busy here and get started on this mounting bracket. Okay, so let's take a look at the drawing here, what we have in store for us. This is a steel part made of mild steel. If you look at the dimensions, for the most part, all the dimensions are two place, or most of the dimensions are two place. That means this is a pretty non-critical part. So with the exception of the tapped holes in the end, those are 3-place spacing because they have to line up obviously with the holes in another part. But other than that, everything else is 2-place. Well, except for that one radius. I think the draftsman forgot to round that off to 2 places. That can be 2-place. So what that tells us is we don't have to spend a lot of time machining all the sides of this part. Okay, I happen to have a piece of 1 by 3-inch steel bar stock. So all I did was saw a chunk of that off. I saved you the trouble, the grief of watching me bandsaw this steel. So I just sawed off a piece 1 9/16 wide. Okay, leaves a 1/16 of an inch for finishing on this one edge, the sawed edge, and then just touch it off on the belt sander to clean up the other sides. That is more than adequate for a part like this. There's no need to machine all the sides on this part because none of them are critical. So that'll save a lot of time. All we really need to do, as far as order of operations, is go ahead and machine this sawed edge. And I think I might take a machine cut on the mounting surface just so it's nice and flat so it matches up with the other part. Then next we'll go ahead and we'll mill these two cutouts in the sides here with a 1/4-inch radius in the corner, so we'll use a 1/2-inch end mill and we'll mill those out. Flip it up on end, drill and tap the 4 holes. Throw a corner rounding end mill in and round these corners off 3/16 radii. And that's pretty much it. So let's get going. Get my long sleeves off here and get some safety glasses on. So like I said, the first thing we'll do is machine this sawed edge. So we'll set the part on a parallel. Okay, practically, we probably don't even have to tap the thing down since none of these edges are critical, but it's a good habit to get into. Hammering your part down, okay, get it tight on the parallels. Let's see, got a fly cutter here and a 1/2-inch collet. So we'll go ahead and get that mounted up. I still haven't got around to repairing my power drawbar since the Harbor Freight impact wrench crapped out on me. But one of these days, like I said, when I get some more time, catch up on a few of these projects in the background. All right, let's get some power going. Okay, we're using a big cutter or a large cutter on steel now, so we have to be mindful of the RPM. This is about a 2-inch cutter. So cutting speed for steel is about 100. So the formula for RPM is 4 times the cutting speed divided by diameter. So 400 divided by 2 gives us about 200 RPM for this fly cutter on steel. So let's go ahead and set that up. Have to go into back gear here. And like I said before, I like to go a little faster with a fly cutter because it dissipates heat so much better than the end mill. So I'm going to run it up to 300 RPM. And we'll go on, bring it down or bring the table up until we pick up the sawed edge. Don't get too crazy about your first cut because this is just to give you something to measure to establish a reference dimension. So just take a light cut on it, just enough to clean up enough to measure. Okay, that's pretty good. Should be able to measure that. So we'll just pop the part out and we'll measure the width of it, see where we are. This finished dimension is 1.5 inches. Right now we're at 1.563, so we have 63 thousandths of metal to remove. All right. So I'm going to set my dial on the table to 63 thousandths before 0. So when I get down to the finish cut, the dial will read 0. Now I'm going to crank it up about, all but 10 thousandths of that and take a rough cut, and then we'll take a 10 thousandths finish cut. Notice from the sound, this is putting a lot more of a load on the machine than that last aluminum part we made. When you're working with steel, you have to be aware of that. Not only reduce the RPM, but you have to kind of be aware of the force the tool puts on your machine as well. A lot of you guys working with lighter bench mills want to make sure and take all the play out of the screw. Right now that cutter's trying to force the table to the back. And if you don't take that play out, it's liable to move the table and dig into the part. So before you start taking the cut, kind of look at it and see which way the cutter wants to move the part, and then take the play out of the screw so the part can't move. The cutter can't move the table against the play in the screw. This is really important if you're climb milling. Then the cutter can dig into the part pretty easily if the table moves on you. All right, so that is the rough cut. Now we'll bring it up to 0, bring the table up to 0 and take finish cut. Again, make sure you're wearing safety glasses especially when you're using a fly cutter. They don't call it a fly cutter for nothing. Chips fly everywhere. It's a good idea to wear safety glasses all the time in the shop, whenever you're working on anything. I was just on the lathe the other day and I was setting up a part. I didn't have glasses on. I was setting up a part on the lathe, and just for no reason whatsoever, the light bulb in the work light failed, and the glass globe just fell off of it. It hit the lathe and just exploded. A piece of glass hit me in the cheek. So you can lose an eye just like that. You're not expecting things to happen like that. It's real easy. Anytime you're working around machinery, you never know when it's going to try and bite you. So it's good to wear safety glasses all the time. It doesn't hurt anything. All right, let's see here. So that should be 1.5 inches wide. Let's double check it. All right, All right, I've been away from this too long. I missed it. Not sure what I did, but we got 20 thousandths to go, so I'm going to take another 20 thousandths on it. Good thing we missed it on the high side and didn't go too far. All right, another 20 thousandths. All right, that should do it. That's better, 1.5 inches, okay? Let's go ahead and take the burrs off. Okay, now that we've got this one edge finished up, let's, like I said, clean up the end here, the mounting surface that has the tapped holes on it. That's theoretically already to size, so we don't want to take much stock off of that, just enough to clean it up. So let's set the part on end. Use a solid square to make sure it's squared up to the vise. And you want to be a little careful with a part on end like this. Let me show you what can happen. Okay, if we were to feed the part like this, you see the cutter wants to push the part sideways. Okay, when the part's standing up like this, that's a long lever arm. It's real easy to tip the part over. Okay, so a better way to take a cut on a part like this is to come over here on the side. I may have covered this in the past, but the first time you do it wrong, it's a real eye-opener. So now if I feed it this direction, the cutter wants to force the part against the solid jaw of the vise, and there's no way it can tip over. It's just one of those things you have to kind of be aware of when you're working on a milling machine. What's the cutter want to do to the part? What's it trying to do? Is it set up properly so bad things don't happen because of it? Just got to kind of be thinking about things like that all the time. Take the play out of your screws so the table can't move if the cutter digs in or tries to load up the part. So I'm just bringing the table up really slow here. I don't want to take too much off because, just like I said, this is already pretty much to size. All I'm going to do is clean it up. There we go, just starting to scratch, so I'll bring it up enough to clean up the whole end of the part. Okay, it didn't quite do it. Let's take another cut. Again, the length of this part, this 3-inch length, is not critical at all. And there's nothing happening there. It can be a 1/4 inch shorter than 3-inch, and it'll still work just fine. So I don't have to worry about going under a little bit on this dimension. Besides, we have a plus or minus 15 thousandths tolerance on it. Alright, so now we have a nice square surface. And I think, while the part's set up right now, why don't we go ahead and put those tapped holes in this surface. No sense setting it up again. So let's switch the cutter out here for a drill chuck, and we'll drill and tap some holes. Alright, so we've got to pick up a couple edges so we know where the heck we are. So we need our edge finder. Let's see, where are we working from here? Okay, it looks like we need to pick up this edge and this edge to locate those holes. Okay, we'll pick up the edge and offset it 1/10 of an inch, which is half the diameter of my edge finder. And our first hole, according to the print, is 0.19 in. It's 3/16 of an inch. So we'll move in 190 thousandths. Do the same thing on this edge. Move in 190 per print. And what do we have here? These are 1032 holes, so I need a number 21 drill for the tap drill. All right, these holes are 470 thousandths deep. Yeah, let's get a little more headroom here. That depth is from full diameter of the drill, so drill in to get full diameter. Set my dial on 0 and crank it up 470 thousandths. There's 470, okay. So that's one hole. Use some coolant on this. Okay, now we're going to move over to the next one. I can either set your digital readout to 0 or your dials to 0 on XY. And move over, let's see, according to the print, 1 1/8 inch, 1 1/8 inches in this direction. About there. And 5/8 of an inch in this direction. 625. and back to 0 in Y. Again, if you're using dials now, make sure, if you go past, don't just come back to it. You got to make sure the play is taken out of your screws, just the way you initially indicated it. Okay, so if we touch the edge like this, we're turning our crank counterclockwise. That means whenever we move to a hole, we have to be cranking counterclockwise. Otherwise, there's backlash in the screw that's going to affect the location of the hole. Okay? So if we come back like this and we go and we stop there, on our number, it's going to be in the wrong position. You got to go past and come back to it, so you're turning counterclockwise on your crank. All right. Okay. Now let's get a tap, 1032 tap. I'm going to power tap this thing, so I'm not going to tighten up the chuck very much. I like to use Tap Magic for steel. Okay. This is the original mixture before they went green and changed it. So this works pretty nice. I have quite a bit on hand. I don't know what I'm going to do when it's gone. The modern stuff or the current stuff doesn't work quite as well, but just have to deal with it, I guess. All right, so let's just go ahead and throw a tap in these guys. See, I got this chuck just tight enough that it, when the tap reaches the bottom of the hole, it'll slip a little bit. It's just a thing you learn from doing it over a period of time, how much tension you can put on it. It's best to start out lighter and work your way up, right, as you learn. So that takes care of that. All right, so now we got the part machined to size, and we got our tapped holes in it. Let's go ahead and let's see what's next here. Let's go ahead and mill these cuts in the sides here, the 5/8 by 2 5/8 cuts. Okay, that goes on this surface here. Okay, we're going to be end milling it from this side, so this has to go up. I like to put marks on the parts, just to make it easier to see what you're doing. So when you're milling, you have a little bit of a guideline. Okay, you can also lay it out with a height gauge on a surface plate, or you can just rely on your dials on your machine and just put a mark on here just as sort of a rough guide. So 2 5/8 long by 5/8 wide. Something like that. Okay, gives you a little guideline. Okay, we'll work off the machined end here. That's the way the part's dimension. No, it's not actually. Well, we're going to locate off that edge, and we'll touch the opposite end of the part with the cutter, and for that 2 5/8 length. Okay, I'm going to use a 1/2-inch 2-flute end mill. If you have a 4-flute, it's more appropriate for steel. I don't do much work on steel, so I don't have a good selection of 4-flute end mills. So you have to be aware if you're using a 2-flute, that's putting a lot higher load on the teeth, a lot higher chip load. So you have to be a little bit careful and not push the tool too hard, or you'll end up with a chipped tooth. Okay, so this cut, according to print, is 520 thousandths deep. Okay, so let's pick up this top surface. Our RPM for 1/2-inch end mill and steel, 4 times the cutting speed. Steel's 100, so 400 divided by half is 800 RPM. So make sure you got your RPM right. And we'll just bring the table up till we scratch the surface of the part. Right there. I want to go down 520, so I'll set my dial 20 thousandths before 0. That'd be 5 turns plus 20 thousandths. I'm going to go all the way down, less 10 thousandths. Okay, we'll leave 10 thousandths for finished cut. Okay, here's what I'm going to do for roughing this out. First of all, I'm going to pick up the end of the part, establish a reference right there, just touch it, set your dial or your DRO to 0. Okay, now we want to go in 2 5/8 inches, 2.630. Right there, okay? And I'll back off like 10 thousandths, just to leave a little bit of stock for cleanup. All right, now I'm going to rough it out by plunge cutting. Oops, you know what? I got to pick up another edge. I got to pick up this edge too. So let's just run until we touch this back edge. Right there. 0 out the dial or the DRO. Okay, now this one is, what would I say, 630 thousandths deep. So we'll move in 630, 0 that out. So now I know where I'm going in that direction, and I know where I'm going in this direction. So we'll stay back 10 thousandths and rough it out. I stayed off 10 thousandths from the bottom, right? So there's 10 thousandths on all edges for a finished cut. So what I'm going to do is plunge cut. That's a lot easier on the end mill than side milling, and faster. You can see we're getting pretty close to our reference lines. It's a good thing. And when you're used to working with aluminum, steel really slows you down. Okay, be careful and not go too far. Stop 10 thousandths shy of our finished position. And I think I'm just going to start working my way down this other way here. Now, here you want to make sure and push your table against the rotation of the cutter, because the cutter is going to try and move the part, okay, before you start feeding. Like I say, be careful how fast you feed it, because you don't want to overload the teeth on the cutter and end up chipping one of them. Just want to kind of judge the depth of your cut by how the end mill's reacting. You know, if it's struggling, if your machine's jumping all over the place, reduce the cut a little bit. I'm going about 100 thousandths a cut here, a little less maybe, and about 50 thousandths a cut. Let me go 100, and you can see what happens at 100. It's probably going to be too much. It's not bad. This is maybe a heavier mill than you guys are using, but you just have to adjust your cut accordingly. I'm going to go back to 50 thousandths. I like the feel of it better. Also keep an eye on the color of the chips. Right now they're just barely starting to turn straw color. Okay, that's a good feed rate. If they start coming off blue, then back off your feed rate a little bit. Don't take such heavy cuts. End mills are expensive. When these chips start coming off blue, it's going to reduce the life of the end mill. Okay, it looks like my battery's about done in the camera, so I'm going to have to take a break here and change out the battery. All right, let's go ahead and finish up this cut. All right, bring it back to the start. Finish roughing it out. Move into about 10 thousandths before a finished position. Starts warming up. It wouldn't hurt to throw a little coolant on it too. I keep some synthetic coolant in a spray bottle. Helps keep things cooled down. This is almost exciting as watching me bandsaw. Yeah, steel's a lot slower than aluminum. All right, so this part is roughed out. Now let's go ahead and finish it up. This might be a good time to demonstrate climb milling versus conventional milling. Okay, if I start from this side and I mill in this direction, this side of the end mill is conventional milling. But if I start over here, go into the edge and mill this way, it's called climb milling. The end mill wants to climb up on this surface. Okay, that's either way works. Those of you guys that have lighter machines might have a problem with the climb milling thing. So you might be better off sticking with conventional milling on all but very small finish cuts. Okay, with this one, I think if I were you guys with a light mill, I might conventional mill down to within 5/1000ths and then just take a 5/1000ths finish cut climbing, because climbing will give you a lot better surface finish than conventional. So let's just go ahead and do that, okay? Let's move in my to within 5/1000ths of my finished position on Y here. Okay, that would be about right there. Now I'm going to lock the table down and I'm going to back my screw out to take up any play so the cutter doesn't tend to pull the part into it, okay? Because I'm going to be conventional milling. The cutter wants to pull the part toward it, okay? So now I'll just mill this edge, okay? This is called conventional milling. All right. Now I'm going to go within 5/1000ths of my finished position, lock down the X table, take the play out of that screw before I start feeding in the Y direction. Okay? And again, that's for lighter mills. I wouldn't have to do all that stuff on this mill, but if you're using a light bench mill, it's always good to lock the table down. It's always good to take the play out of the screws. All right, now for finish cut, I'm going to climb mill. Okay, don't forget we have 10/1000ths on the bottom to cut off, so I'm going to raise the table up 10/1000ths. That'll take the finish cut on the bottom. Okay, I'm going to bring my table in this direction till it reads 0, till the dial reads 0, or the DRO. Okay. Then I'm just going to climb mill this edge. It'll make a nice finished surface. Okay, I'm going to go right in till my Y reads 0. Right there, okay? And then I'm going to feed in this direction. You don't have to be too concerned about locking. Well, I shouldn't say that. You may want to lock the X table when you're climb milling like this, because the cutter wants to climb up on the part and push the table in that direction. So it wouldn't hurt to drag your lock on the table a little bit on the X axis, just so that doesn't happen. Again, a mill like this, it's not critical. You don't have to do that, but on a light mill you do. All right, now I'll just move over and just clean up this last little bit on the bottom. And this side is done. This cut is done. Okay. All right, so now let's flip it over and do the same thing on the other side. Take some burrs off here so they don't get in the way. These things are handy for removing burrs on radii. There we go. All right, that takes care of all those burrs. Now I might need to change my parallels a little bit here. If I flip this part over, it's not much to grab anymore, right? So I'm going to go to a shorter parallel. Looks like about 3/8 of an inch shorter in this case. Make sure all the chips are cleaned out from the vise. Okay, there we go. Now the vise grips the full length of the part. Okay, we still have the stop set for the end, so we don't have to pick up the end of the part anymore, but I do have to pick up this front edge. Now we're working from the front. Before we worked on the back, but I flip the part over now. So now we got to work off the front. So it means we have to pick up this edge again. And we have to pick up the top because I changed parallels. Let's do that first. Okay, set my dial for the top. Again, less 20 thousandths because we're going to 520 deep. Okay, so I'll go 1, 2, 3, 4, 510 thousandths shy of 520. Just like before. Now we'll pick up this edge. About there. Now we do the same thing as we did on the other side. I'm not going to make you guys sit through that. So I'll go ahead and finish it up and then we'll get started on the next operation.